All right, so bringing you a quick video on our foldable on how we're going to solve systems using substitution. There's going to be two different styles of problems. One, like number 5 right here, this is like a ISO versus a ISO. And over here on this side, we'll have a situation that's like an ISO versus a sub, okay? Sub meaning substitute. These two types of problems will be solved differently, but overall, the concept stays the same. We're going to be using substitution, okay? So the first thing we want to do is we want to isolate one of our equations for one of its variables. When we say isolate, we're looking at example number 1 right here. You see how x is isolated on one side all by itself. This is going to be my ISO, okay? No work has to be done other than seeing. Same thing here. For example 2, y is isolated right here. So this is going to be my ISO equation. Right here, nothing is isolated just yet, okay? So for example 3, we'll have to do a little bit of work to isolate y right here, okay? That would be the easiest variable to isolate. So first step is to isolate one of the equations for one variable, whether it be x or y. After that, we're going to substitute the expression from our first step, from our ISO, into the other equation and solve for the remaining variable, okay? So again, when you see a problem, you'll see an ISO equation. Automatically, this guy needs to be our substitution equation, okay? ISO sub. You got to have an ISO and a sub in order to use the substitution technique. And last but not least, after we do all of that good work and we solve for one variable, we're going to plug in the answer from step 2 into the original to solve the equation for the other variable, okay? So let's go ahead and start here. Let's see what we're talking about here. First thing I want to do is identify a variable being isolated, whether it be x or y. So right here in example 1, this is my ISO. Therefore, this guy right here is my substitution equation. What I must do as a student is rewrite my substitution equation. Negative 2x plus 9y equal to 8. Using your eyeballs, you are going to identify who is being isolated. We are isolating x, so in your substitution equation, you're going to plug in what x is equal to, okay? Just x. And according to this problem right here, it says that x is equal to y plus 3. We're going to change x to y plus 3. Now, originally, what goes in front of x? 2. Actually, a negative 2. What goes behind the x? A plus 9y equal to 8. If you make it here, you are on track. You're on track to do something great, okay? This is what substitution looks like. Find the variable that's being isolated. That's this x right here. X is equal to y plus 3. That way we got all y's right here. We can solve for y. And here's how we're going to work that out. First thing we're going to do is substitute negative 2 inside the parentheses. That's negative 2y minus 6. Bring down the positive 9y. Bring down the 8. Then we're going to combine like terms. My like terms over here, negative 2y and 9y. That's going to be 7y minus 6 equal to 8. Then I'm going to add 6 to both sides. Get 7y equal to 14. And then I'm going to divide by 7 on both sides. Y is equal to 2. We did it. We just solved for y. And we're excited about it because we're halfway done through the work. Now, the last thing we got to do is solve for x. And it tells us right here, x is equal to y plus 3. We're going to take our answer, y is equal to 2, and we're going to plug it in right here. So 2 plus 3 is 5. X is equal to 5. Final solution is going to be X comma Y, which is 5 comma 2. Easy work. Easy work. If there's any questions, of course, you can pause the video and play it back again. If you still have questions after that, you need to ask your teacher specifically what you need help with. Let's move on to example 2 here. For example 2, we have an ISO situation right here with the y equals. So we're going to rewrite our substitution equation. Substitution equation is 3x minus 4y equal to 31. This time we're going to go to our y, and we're going to plug in what y is equal to. Negative 2x plus 6. And bring down the rest of the problem back into it. So after the y, we got minus 31. In front of the y, we had a negative 4. And in front of that negative 4 was 3x. This is where you want to be. You got to get this if you're going anywhere. And now let's work it out. We're going to start by distributing. Negative times a negative, that's positive 8. Negative times a positive, that's negative 24. We're going to combine like terms right here. I'm pretty sure that's 11x. We're going to add 24 to both sides. That's going to be 55. Then we're going to divide by 11 on both sides. X is equal to 5. X is equal to 5. Now, with x being equal to 5, we're going to plug it in for y. We want to solve for y. Y equals negative 2x plus 6. We're going to plug in our 5 right here. That gives us negative 10 plus 6, which is negative 4. Y is equal to negative 4. Final answer is x, comma, y. Any questions? Going once, going twice. Remember, you can pause the video and slow this thing down a little bit, but I am going to example number 2 here. When I get to example number 2, oh man, I don't have an ISO situation. Mathematically, I want to do it with this one here, okay, because y is almost by himself. Just got to get rid of this 3. Now, because these two things are multiplying, I'm going to divide by 3 everywhere to get my ISO equation. Y equals 5x minus 1. Cool beans. This is going to be my new ISO. Automatically, this guy becomes my substitution equation. And we write it out. If you want to, you can like kind of disregard this guy. Now, we're not really focused on him. We should always go back to the original, but let's stay focused. Negative 5x plus y equals 4. We're going to substitute for y because that's who we're isolating. Y is equal to 5x minus 1. In front of that y is a plus sign. In front of that plus sign is a negative 5x. And on the back side, there's a 4. And we should get ready to solve this by distributing. Y'all see the 1 right there? That's a positive 5, and that's a negative 1. Drop down to negative 5x. Oops, that's not a negative 4. We're going to combine like terms right here. Whoa. Negative 5 plus 5 is 0. We're left with negative 1 equal to 4. Is this a true statement? Absolutely not. This is a false statement. So your answer would be no solution. These will be parallel lines that do not cross. Your answer right here is no solution for example 3. Again, right here, after we distribute this positive 1, we end up with positive 5x minus 1. These two are going to cancel each other out, okay? Don't write x at all because it's -5 plus 5, which is 0. So you cross it out. You're left with this. This is not a true statement, okay? This is a false statement, so it's no solution. Moving on to example number 4. In this one here, this is a different situation, okay? Right here it says follow the same steps as linear equations, but if you have to solve a quadratic, you must factor. Ooh, you must factor. A times C, B, go looking for those two numbers. Y'all remember that. Or use the quadratic formula, -b plus or minus b squared minus 4ac divided by 2a. If you want to, all right? If you want to. But regardless, here's what we have right here for this problem in particular. We're looking for isos, okay? We actually have a double iso right here. Both equations starts with y equals. Now, because y is equal to, let's make that blue, 2x minus 4, and y is also equal to x squared minus 4x plus 1, we have to set these two things equal to each other. You create a substitution equation, okay? Now, here's how that looks. Due to identity properties, y is equal to y. That's a given. So we can also assume that 2x minus 4 is also equal to x squared minus 4x plus 1. And now that I've written this, I'm going to rewrite it for one simple reason. You see this x squared on over here? And I want my brain to not get scrambled. I'm going to rewrite this with my x squared already on the left side. Why? Because I want to. If you don't want to, you don't have to. But I am. And voila, we set these two things equal to each other. This is how you run a double iso, okay? So here we go. In order to solve this, because it's a quadratic, I want this side equal to 0. So what I'm going to do is subtract 2x from both sides. And I'm going to add 4 to both sides. That's going to allow me to cross both of these out to get 0. And over here, I should have x squared minus 6x plus 5. Easy money. Now, this is where you start factoring. I'm looking for two numbers that add up to -6 and multiply to 5. Those two numbers are 1 and 5, both negative. I'm looking for two numbers that multiply to 5, add up to -6. Those two numbers are -1 and -5. So I go x minus 1, x minus 5 equal to 0. I set both parentheses. Oops. I don't want to speed through that. Set both parentheses equal to 0. So right here, we'll add 1 to both sides. X is equal to 1. And over here, x minus 5 equal to 0. Add 5 to both sides. X is equal to 5. So right now for my two solutions, I got 1, and the other one I got a 5 in for my x. Now what are my y values? I can use any one of these right here. I'm going to use the linear one. I'm going to type this into the calculator. First one being 2x minus 4. Again, use your eyeballs. 2x minus 4. I said x is equal to 1, so it's 2 times 1 minus 4. I put this into the calculator. You'll get 2 minus 4, which is -2. There's my first solution. I'm going to do the same thing with the same equation right here, 2x minus 4. I'm going to do it for my second point. That's going to be 2 times 5 minus 4, which is 10 minus 4, which is 6. These are my two solutions. Easy money. 10 minus 4 is 6. I'm pretty sure it is. Correct me if I'm wrong. But if you've lost that skill of factoring, finding those two numbers, we got to sharpen it up. And here we go. We got another ISO situation. Okay, cool. Now, looking at my x squared, I'm going to go ahead and put him on the other side this time because he's going to be someone I'm going to move. So negative x plus 5 equal to negative x squared minus 4x plus 5. Remember, that's the identity property. Y is equal to y. We can assume that. It's called identity property. Now, I want this side over here to be equal to 0. So we're going to add x squared. Now you can see why I put it over here on this side. We're going to add 4x and we're going to subtract 5. What you do to one side, you do to the other. Minus 5 plus 4x and plus x squared. Gone, gone, gone. We got 0. Now over here we got 5 minus 5, which is 0. We got 1, negative 1 plus 4. That's going to be 3. So plus 3x. And over here, bring down your x squared. Voila, there we go. We got it. Now, in this situation, we're missing the c value. Remember, we crossed it out because that's 0. How do we factor this situation? In the situation where you're missing c, you're going to use GCF. So what can I take away from x squared? I can take away an x. What can I take away from 3x? I can take away an x. That's what they all have in common, a single x. What that turns the problem into, since we got x as a GCF, x squared becomes a single x, and the 3x just becomes 3. We can get back to the x squared plus 3x by distributing. Y'all see that? Yeah. Y'all see that? X times x, x squared, x times 3, 3x. Same thing. All right? Again, you do this when your c value is missing, okay? So we set both parentheses equal to 0. That's x equals 0. And then we set x plus 3 equal to 0 minus 3 on both sides. X is equal to negative 3. Right now, these are our two solutions because both of these have to be set equal to 0. So I got two solutions ready to go. First one is going to be at 0. The second one is going to be at negative 3. What are my y values? As you can imagine, I'm going to use this guy up here. Negative x plus 5. Negative x plus 5. For this first one here, I'm just going to plug in 0 into the parentheses. When x is 0, y is equal to 5. There's one answer. When x is equal to negative 3, that's a double negative right there. So that becomes 3 plus 5, which is 8. So those are my two solutions right there. 0, 5, and negative 3, 8. Easy money. I just got to find these guys, though, all right? Remember, you can use factoring or you can use the quadratic formula. Again, when you're here, you got to know that your c value is 0 if you're going to use the quadratic formula. All right? If you're going to use the quadratic formula. One more. Again, we got a double ISO being ran right here. This is going to be x squared plus 5 equal to x minus 2 squared plus 1. How? How would I get everybody on the same side? What I would do, I would change this to standard form. Remember, that's going to be x minus 2 times x minus 2 plus 1. X times x, x squared, x times negative 2, negative 2x, negative 2 times x, negative 2x, negative 2 times negative 2, positive 4. Bring down the plus 1, and you'll get a 5 at the end. And then, oh, we also got to combine those two as well. This becomes x squared minus 4x plus 5. All right. Again, we got to multiply using FOIL to get all of this goodness right here. Make sure you combine like terms in the middle. And on the back end, oops. On the back end, you got the 4 plus 1. Remember, the 4 came from doing -2 times -2. Bring down the positive 1. That's how we get to 5. Now, we're going to set all of that equal to x squared plus 5. Now, whoa. Look what happens to the x squared on this one. Subtract x squared. Also, I'm going to go ahead and subtract 5. My zeros on this side, I am left with -4x. Yeah, because my x squared gets crossed out and my positive 5's got crossed out. From here, I'm going to divide by -4 on both sides. X equals, oops, 0. X is going to be equal to 0. Now, with x being equal to 0, what is my y value going to be equal to? I'm going to use this guy right here. X squared plus 5. Put a 0 in there. You end up with positive 5. So this is one solution. This is one solution, okay? Whereas these other two up here had 2 solutions. Again, when you're dealing with quadratics, you can have up to 2 solutions. Sometimes you can have one solution, and sometimes you can have no solution. It's a thing. But this has been a lengthy video. Again, we're going to go over this in class together. This week, we will take a quiz on Friday, all right? If you are ready and available to start on Wednesday or Thursday, that's cool. We can get it started then. But the goal for this week is something we got to get used to. The goal is to start and finish. Right now, a lot of people are not getting to this piece cleanly, okay? It's disruptive. It disrupts the flow of the class. We end up having to spend extra time on old things and make it hard to move forward. So again, if you want to start the quiz on Wednesday or Thursday, make sure your plan is to start and finish. If you are quizzing on Friday, you will start and you will finish. All right. We don't want too many NFs. Okay. Signing out.